All right, we will get started on section 5.4, picking up where we left off before Christmas break. So 5.4 is on the addition rule for disjoint events. What is the addition rule and how does it help calculate probabilities and disjoint events? It should be of disjoint events. All right, so a couple definitions. Disjoint events are events that do not overlap. They're also called mutually exclusive. So like in here we would say A and B are disjoint, which can also be called mutually exclusive. Okay, and a complement event, everything that is left over from another event. And I can zoom in a little bit. So if you haven't written this down, go ahead and pause it. I'm going to zoom in now. So you have A, and then you have this thing that looks like A with a C as the exponent. This is called the complement of A. Right, so it's kind of like this. If you roll a dice, that's six-sided. So like you want to find out what is the probability that you roll a 1. Okay, the complement of that would be what is the probability that you do not roll a 1. So that's how complements work. It's kind of what you're not looking for, the opposite of something. So probability of rolling a 1, probability of not rolling a 1 is the complement. Okay, probability rules. Rule number 1 is any probability is a number between 0 and 1 inclusive. So that means the probability of an event, we're going to call this event A, is less than or equal to 1, and it's greater than or equal to 0. Okay, the probability cannot be less than 0, and the probability cannot be greater than 1. Because 0 means it doesn't happen, and 1 means it's 100% going to happen. So you can't go above that, and you can't go below 0. Rule number 2 is all possible outcomes together have a probability of 1. So if S is the sample space, then the probability of the sample space, so probability of something in that sample space happening, is equal to 1. So if you roll a dice, and you want to know what is the probability of getting a 1, 2, 3, 4, 5, or 6. The probability of getting a 1, 2, 3, 4, 5, or 6 would be 1 or 100% because you're guaranteed to get one of those. Rule 3, the probability that an event does not occur is 1 minus the probability that the event does occur. So the complement of any event A is the event that A does not occur. So the probability of the complement, which is A with that little c as an exponent, the probability of a complement happening is 1 minus the probability of A. Okay, and rule 4, two events A and B are mutually exclusive if they have no outcomes in common, so they never occur simultaneously. So they're mutually exclusive if they have no outcomes in common and they never occur simultaneously. So if A and B are mutually exclusive, then the addition rule for mutually exclusive events is as follows. This means that symbol in between it looks like a U. That U looking symbol means the probability of A or B happening, which is equal to the probability of A plus the probability of B. So think of it this way. If you're rolling a dice, if you want to know what are the chances that you roll a 1 or a 2, that would be the addition rule. Because you can't possibly get a 1 and a 2 at the same time when you roll a dice. So to do this, you would do, okay, what is the probability of rolling a 1 plus what is the probability of rolling a 2? That's how the addition rule works. So in example 1, they tell us a sociologist studies social mobility in England by recording the social class of a large sample of fathers and sons. The social classes are ordered from class 1, which is the lowest class, to class 5, which is the highest class. Here are the probabilities that the son of a lower class father will end up in each of the social classes. So it's kind of like saying, think of it this way, your father is very low class. Think of it as like he doesn't make a lot of money. Okay, he's in that low class. And think of it as class 5 is like become really rich, have a ton of money. So that's how the class system kind of works. Think of it that way. So A is the son remains in class 1. And B is the son reaches one of the highest 2 classes. So if you look at this table, so if the son is born to a father who's in class 1, there's a 0.48 probability that he stays in class 1. There's a 0.38 probability that he goes up to class 2. The son eventually goes into class 2. There's a 0.08 probability that that son who was born in class 1 ends up making a lot of money and goes to class 3. There's a 0.05 probability that the son who was born in class 1 ends up making a lot of money and getting to class 4. And lastly, there's a 0.01 probability that a son born in class 1 would reach class 5. Class 5 thinking as in like being very, very rich. So if you're born very, very poor and you become very, very rich, it's a 0.01 probability. So all these highlighted numbers, let me erase them, I don't want that there. If you notice, when you add them up, 0.48 plus 0.38 plus 0.08 plus 0.05 plus 0.01 would add up to 1. If you add them all up, you will get 1. So basically, when the son is born, he's guaranteed to end up in one of these 5 classes. He's got to be in one of them. So what is the probability of A? Well, A is that the son remains in class 1. So what is the probability that the son will remain in class 1? 0.48. Which is like a 48% chance. Part B says, what is the probability that of B? Oops. And B is the son reaches one of the highest 2 classes. So the highest 2 classes are class 4 and 5. So the probability of reaching class 4 is 0.05. The probability of reaching class 5 is 0.01. So the probability of reaching class 4 or class 5 is 0.04 plus 0.01. So 0.06. So there's a 0.06 chance, or a 6% chance, that the son born in class 1 would reach class 4 or 5. Part C says, what is the probability of the complement of A? Okay, the complement of A is 1 minus A. So this is going to be 1 minus the probability of A. And up here is the probability of A. So this is going to be 1 minus 0.48. So it'll be 0.52. So this basically says what is the probability that the son does not end up in class 1. So it'll be 1 minus the probability that he does, so 1 minus 0.48. And then part D is probability of A or B. So we just take the probability of A, which is 0.48, plus the probability of B, which is 0.06. So there's a 0.54 probability that the son will either stay in class 1 or go up to class 4 or 5. Okay, and then example 2 kind of used that dice example. This time it's a 10-sided dice. So when rolling a 10-sided die, the numbers are 0 through 9. What is the probability of rolling a 5? Probability of rolling a 5. 5 is one number on there, and there are 10 total. So the probability of rolling a 5 is 0.1. Part B. If A is getting a 1, 2, or 3, what is the probability of A? So 1, 2, or 3, that's 1, 2, 3 outcomes out of 10 total outcomes. So 3 divided by 10 is 0.3. In part C, if B is rolling a 6, 7, 8, or 9, what is the probability of B? Well, 6, 7, 8, or 9, there's 4 numbers. So 4 out of 10 would be a 0.4 probability of rolling a 6, 7, 8, or 9. And then part D, what is the probability of A or B? So the probability of A is right here. Probability of B is right there. So the probability of A or B is 0.3 plus 0.4, which is 0.7. And then lastly, if C is 0, 4, or 5, what is the probability of B or C? So the probability of B is 0.4. And the probability of C, there's 1, 2, 3 numbers. So the probability of C is 3 out of 10, which is 0.3. So 0.4 plus 0.3 is 0.7. Okay, so whenever you see the word or, go back here and highlight this. Whenever you see the word or, it means you're going to add them up. So probability of B or C is you add up the probability of B plus the probability of C. Likewise, probability of A or B is when you add the probability of A plus the probability of B. And that is the addition rule.